Good morning, and thank you for joining us for today's webinar. We're going to be talking about the 2022 eFields results. So for those of you who are not familiar with the eFields program, I just want to give a quick recap of what that entails. So eFields is Ohio State University's on-farm research network, and it was developed to engage farmers in the research process. We want to hear from farmers across the state and country about what decisions you need help making on your farm. And then we want to empower you to use your farm data and experiment with on-farm research to help you find the best answers to those questions. Together over the years, we've developed several standardized protocols that are available for your use, including popular topics like seeding rate, nitrogen management, newer topics into fertility like sulfur, and phosphorus placement, as well as some trials looking at technology like planter speed and downforce, and then some of the things we'll talk about today, including soil health and cover crops. Since eFields was started in 2017, as you can see here, we've had tremendous growth, and our 2022 report we're excited to share with you has over 290 trials that have covered almost 50 counties in Ohio. We're really grateful for our on-farm research partners that we work with, including our partner farms and our industry partners. Without you guys, this would not be possible. So we're incredibly grateful for your willingness to work with Ohio State and help advance knowledge in areas that matter to Ohio farmers. So if you haven't been able to get a printed copy of the report and you want to follow along today, you can scan the QR code on the screen, or you can go to our website, which is go.osu.edu/eFields. And there you'll find the 2022 report, our most recent, as well as all 6 eFields reports that we have published to date. So go ahead and get that pulled up on your computer, and we're going to get ready to get started. Joining us today, we've got a great lineup of speakers from our Ohio State collaborators. We've got Chris Zoller, Jason Hartschuh, Nick Eckel, and Amanda Douridas. And the 4 of them are going to share some of the results from their local trials and things that they're seeing around the state. We're going to dive in a little more in depth. So to start off with today, I'd like to introduce you to Chris Zoller. He's our ag educator in Tuscarawas County, and he's going to share about some trials that he conducted, including fungicide application and some corn seeding rate results. So take it away, Chris.
Hello, my name is Chris Zoller. I'm Extension Educator for Agriculture and Natural Resources in Tuscarawas County. I appreciate the invitation to be here with you today to be a part of the Precision U program and to share with you a little bit of the eFields work that I've done in 2022. The first one I'll share with you is from Ayers Farms. That's a dairy farm that grows corn, corn silage, soybeans, rye, and a lot of forages that are fed to the dairy cattle. And their first year in eFields was in 2021. They had heard about a study I had done with another dairy farm looking at corn row width, and it was something they were interested in exploring further. It was something that they were considering making an investment in being able to do that, but they wanted to get some data collected before making that investment. And so that was the first on-farm trial that they did with us. They enjoyed it, found value in it, and in 2022, prior to that, they contacted me and said, we're going to apply fungicide to all of our corn this growing season, and what we'd really like to do is compare application methods. Can you help us? And so working with my colleagues, including Jason and Elizabeth, we developed a protocol and carried that protocol out on this particular farm and had some interesting results. So the objective here basically was to look at 2 application methods, one being aerial, the other being ground, and then what effects did we see, if any, on plant health and final yield. So to give you a little bit of background information, this was planted on the 15th of May and harvested on the 4th of November. It was a Seed Consultants 1087 variety, and it was planted at 33,000 seeds per acre across 100 acres. The fungicide applied was Moravis Neo, applied at 13.7 ounces per acre, and the application was made on the 26th of July. So what did we find? Well, this table I show here has three columns. The first one says treatments. And so our treatments, again, that's our aerial, our ground, and then the control. So no fungicide was applied in our controls. The moisture you can see there was fairly close, a little over 17 to just over 20% moisture. And then our yield is the final column, of course, bushels per acre. And so aerial came in at 243, ground was 239, and our control, where no fungicide was applied, came in at 198. Now you'll notice in that yield column that the aerial and ground values are followed by the same letter. It happens to be the letter A. What that tells us is that statistically speaking, there's no difference in those yield numbers. Now you'll notice also that the control has a different letter following that number. That's a letter B. What that tells us is that if we compare the control to the application methods, statistically speaking, there is a difference in yield. And it's rather obvious when we look at those numbers. We're looking at 40 plus bushels more based on those strips that did receive fungicide. So in this case, certainly paid to apply that fungicide. Just to summarize briefly a few points here about this particular study. Again, no statistical difference in application methods, but as we compare application methods to a control where nothing was applied, we do see a difference. We had some disease pressure come in, included gray leaf spot and tar spot. The tar spot was not real severe and it came in late, and so we don't think it really impacted final yield. And then as we look at application costs, we compare the aerial application to the ground application. On this farm, in this particular situation, the aerial was $3.78 per acre less than the ground application. So some pretty interesting research in this area, and one that has garners a lot of questions from growers and crop consultants and such. So the next study I want to share with you is conducted at Spillman Farms. It's a corn, soybean, wheat primarily. They do grow some hay, raise a little bit of beef cattle, but the main focus is agronomic crops. And they've been involved with this program since eFields began in 2017. Excellent partners to have, and really appreciate their willingness to be a part of the program. A few of the prior studies that we've done with Spillman Farms include seeding rates, both corn and soybeans, fungicide application on soybeans, nitrogen placement, and then last year they wanted to do another corn seeding rate study. So again, the objective here is to determine what effects, if any, is there on final yield based on those planting rates, populations that we have. And so it was planted on the 9th of May, harvested in early October on the 8th. It was a channel 21079 DG variety. And we had three planting populations, 31,000, 33,000, and 35,000. It was a 10-acre field, 3 replications, and of course, the 3 treatments. So what did we find? Well, the table I show you here, first column is treatments, and so that's the 31,000, 33, and 35,000 seeds per acre. The next is average emergence, had good emergence. The next one is moisture, very similar moisture levels there. And then we get to yield. We have 194 at the 31,000 rate, 198 bushels per acre at the 33,000 rate, and 195 at 35,000. And then the last column you see there is return above seed cost. And so we look at, based on each of these seeding rates, which one provided the greatest return above our seed cost. And so in this case, the 33,000 seeds per acre had not only the highest return above seed cost, but also the highest yield. It's not always the case that is the way it falls out, but in this particular situation, we did see 33,000 maximized yield and returned the most above seed cost. So just to summarize this one, again, we evaluated 3 seeding rates, 31,000, 33,000, 35,000. No significant difference between those treatments. We did have some drought conditions that came in, especially during pollination. That was evident by looking at the ears and the tips of those ears especially. No disease or insect pressure. So we didn't see tar spot, we didn't see gray leaf spot, we didn't see any particular pressure in that respect. So again, a great study to be involved with, and appreciate the assistance from all these farms. Happy to take any questions if anyone has any questions that they'd like to answer now or at a later time. Or if you want to follow up with an email or a telephone call, I'd be happy to talk to you about that. Thank you.
Thank you, Chris. Chris has been one of our original collaborators, and it's wonderful to work with him and see the relationships he's built in his county and then the results that we're seeing that he can share statewide to help everyone. Next up, we've got Nick Eckel. He is our extension educator in Wood County, and today he's going to talk about some local trials that he conducted using the Xyway fungicide and as well share some of the statewide results we're seeing.
Hi, I'm Nick Eckel, OSU Extension A&R educator in Wood County. This past year, I had the opportunity to work with a local grower in my county and doing on-farm research and a study of Xyway fungicide and its response to overall plant health throughout the growing season, focused on the control of tar spot. We also took these plots to yield at the end of the season to see if there would be a statistical difference between the treatments. Our study consisted of 3 treatments. One was just Xyway itself that was put on by the planter in a 2x2. The second was Xyway along with an application of Veltima fungicide that was put on at the VT growth stage. And the third was our control treatment. We replicated these treatments randomly 4 times through the field in 2 separate locations. Each treatment was 60 foot wide and at field length. Throughout the growing season, initially, we took early season vigor and uniformity notes as the plants emerged and the overall stands in the field. And we wanted to see if the Xyway had any adverse effect on overall plant population and early season vigor in the cold soils that we had. When we walked the field and scouted, our populations were right on where we wanted to see, and the uniformity was very uniform, where all plants were up between a 24 to a 36-hour window. Kind of came back and forth early on to see what was going on there, but we did have some cold snaps early on to kind of hinder the overall growth and vigor of those plants. But once we got those plants up and on the ground, it was still very uniform. We also observed overall health at the V5 growth stage. We had a large rain event in June, and we wanted to come back and see once if that had any effect on our overall stand, and if the Xyway helped or hindered us throughout the growing season at that V5 and with the water stress. There wasn't enough uniformity based on where the water was and wasn't, but just kind of walking it, we didn't see any adverse effects or benefits from the Xyway through those treatments. Then we came back at the VT growth stage, and we were looking for any disease right before we sprayed fungicide. At that time, the control had a 1% gray leaf spot coverage. Very early on, we started to see some specks here or there. As we walked the other 2, which had the Xyway on them, those 2 were still very clean. So we were really happy growing into reproductive stages that we had good plant health at that time. We then came back at R5 to see if we had any late season disease start to set in through August. So in the first field that was planted in May 15th, our tar spot in our control was 6%. Northern corn leaf blight was a 3% leaf coverage, and gray leaf spot was a 4% leaf coverage in our control. Xyway, we had 2% of tar spot, 1% coverage on northern, and 3% coverage on gray leaf spot. Xyway plus foliar, we saw our biggest benefit of stacking those 2 products on overall plant health. 1% tar spot, northern corn leaf blight was 0%, and gray leaf spot was also 1%. In the second field, in that May 23rd planting, tar spot in our control was also 6%, but northern was a 0% and gray leaf spot was 1%. Xyway in our Xyway alone on tar spot was 2%, northern was 0%, and gray leaf spot was 0%. And Xyway plus foliar, we had a 1% coverage of tar spot, 0 on northern and 0 on gray as well. So we did see a major benefit of stacking those 2 products. We maybe had a little bit better control or agronomics on one variety from another on the northern and the gray as well to help control those. So overall, as we moved into the fall and started to harvest this and take them to yield, our first plot study in our control was 218 bushel the acre. Xyway alone was 223 bushel the acre. Xyway plus foliar was 221 bushel per acre. In this trial alone, it showed no statistical difference between the three different treatments. As we moved into the second field, control was 223 bushel per acre. Xyway alone was 233 bushel, and Xyway plus foliar was 226 bushel per acre. Now this field, we did see it did show a statistical difference between the three treatments. So this would be one of those fields that we could start to see some trends in and account for this data to be relative. As we moved into the statewide results and as we composite all the results from all the different Xyway trials that were done throughout the state, there was no statistical difference between the three treatments that we did. We did not see any trends or consistency between those results. And so with that, there's just a lot of noise and couldn't really figure if it was a Xyway or if it was a weather thing, probably more than anything. But I hope that you can take this information and allow you to make better management decisions on your farm. And we hope to continue these trials in the future, because I think it really does help farmers when they start to make decisions for themselves. Have a good day.
Thanks, Nick. That's really interesting that you're sharing this information. I think it's very valuable as new products like this come onto the market, being able to quickly generate information about how it's performing on the farm. Next, we've got Jason Hartschuh. He is our field specialist in dairy management and precision livestock. And today he's going to be sharing some results that he's seen with quality in corn after some fungicide foliar applications.
Foliar fungicides can have some additional benefits beyond potential yield increases that include improving grain quality and forage quality, which is important for Ohio's livestock industry. In Crawford County this year, we had a trial that looked at comparing two different hybrids and three application methods. Our three application methods was an untreated control, 20 gallons per acre over the top, and 20 gallons per acre utilizing undercover drops. At 20 gallons per acre, our application over the top appears to do a decent job of getting some of that fungicide down to ear level. The reason why ear level is important is we also wanted to look at dawn levels in the corn and see if we could reduce dawn levels with either fungicide application. Unfortunately, I don't have dawn levels to share today, but I do have our visual ratings of the ears. But when looking at grain, we didn't see any difference in grain yield between hybrids or application methods. Our hybrid with a weaker disease package still had resistance, but just not as higher ratings as our stronger hybrid, showed a 205 bushel grain yield, either control or treated. Our stronger hybrid disease package had a 203 bushel yield, control and utilizing drops. We did see a slight increase when we went over the top, but there was a lot of variation in this field, so it wasn't a significant increase in yield from foliar fungicide application over the top. Some rainfall events caused a few areas of this field to drown out and caused some other variation across the field, but we were able to remove those drowned out areas and other areas of significant reduction in plant population. When we looked at ear quality, we did see some differences. The ear on the right is the stronger variety in the untreated control, and the ear on the left was foliar fungicide application over the top. Looking at those, we can see some cob size difference, but we could really see some differences in cob quality when we shelled the grain off. The ear on the very right is that untreated control ear. We could see visual stalk rot that may correlate to increased dawn levels in our corn grain samples. But we'll have to wait and see on those results. We had a corn silage trial this year up at Hoytville, utilizing three varieties: a corn grain variety that was a silage type, so it was a leafier variety, potentially higher digestibility, and then 2 BMR varieties, older genetics that were more susceptible to disease, and a new generation with a better disease package, and 4 fungicide applications, control, VT undercover drops, over the top, and a V5 application. Looking at yield, the traditional silage variety and the new generation BMR had no effect of foliar fungicide application. The older genetics, though, the older BMR did. Most of that came from an increase in starch levels. When we come over to the graph on the right, starch levels are in blue, and we had significant increase in plant starch with that foliar fungicide application utilizing drops. We didn't really see an increase in total starch across any other varieties. Starch is also a proxy for an increase in grain yield. Although we are also concerned in corn silage about total energy that the animal can extract from that plant. When we looked at total energy, which is the orange dots, we didn't see a fungicide effect on that traditional variety. However, both BMR varieties showed a trend towards increased plant energy with the fungicide application. The older generation BMR showed the greatest effect of foliar fungicide on total plant energy. We saw a significant increase both with drops and when the foliar fungicide was applied at V5 over the top. Trend-wise, we also saw that same increase with a fungicide application at VT over the top. This trial was very noisy, and if we go back to the tons per acre, you'll notice that we only grew about 16 tons per acre of corn silage. That was attributed to a rain right after planting that caused some emergence challenges. All varieties struggled the same to come out of the ground with an equal population reduction, but that caused us to have lower yields than we would have expected. We ran whole plant DON analysis and multiple vomitoxins on the corn silage, and we did see an effect of both variety and application method to DON reductions. The goal in a dairy ration should be for your corn silage to really be under 1 part per million, but 2 parts per million can be diluted out to have a total ration of 1 part per million. Our untreated control across all varieties was a little over 3 parts per million. When we utilized the fungicide with the VT drop, we were about 1.7 parts per million. VT over the top, we were down to a 0.5 part per million. And our V5 application actually reduced us to about 1.2 parts per million. DON and corn silage can come out of both the stalk and the ear, making whole plant coverage very important. And the drops we used covered very well from the ear up, but didn't get much fungicide down below the ear, where our over-the-top application got some fungicide a little bit lower on the plant than ear level, which may be why our VT over the top had our lowest DON levels. That was significantly lower than our control or our VT drops. Our variety also had a significant effect. Looking at variety across all treatments, our older generation BMR variety had the highest DON levels, about 2.2 parts per million. Our new generation BMR was just under 1 part per million, and our conventional corn genetics was about 1.6 parts per million, showing that fungicide and variety have an effect on DON production. Our last trial, looking at both DON and grain yield, was applied at VT utilizing a ground rig compared to an untreated control. We saw no difference in grain yield with 202 bushels per acre in our control and 109 bushels per acre in our treated. Our fungicide was Miravis Neo. We did see a significant reduction in DON by doing truckload samples. Our field is big enough that we had multiple truckloads of untreated control and treated. Our untreated was 3 parts per million higher in DON than our treated with Miravis Neo, showing that reduction. Although other fungicide trials have shown us that DON reduction can be very variable and timing is absolutely critical. This fungicide was applied while the silks were still wet. Thank you, and back to you, Elizabeth.
Thank you, Jason. I think this is really critical research, not only for our livestock farmers, but also for our grain farmers in Ohio to make sure that we're providing top quality feed. Next up, we've got Amanda Douridas. She is our extension educator in Madison County, and today she's going to be sharing a very interesting trial that she's been working on, looking at soil temperature and moisture under cover crops and fields that were not cover cropped moving into the planting season.
Hello everyone, I'm Amanda Douridas, Madison County Agriculture Natural Resources Extension Educator, and today I'll be talking about some research that Dr. Elizabeth Hawkins and I have been working on, looking at soil moisture and temperature under different management conditions. So our objective of this study was to determine how soil moisture responds under different field management situations for planting, and we'll look a little bit at temperature as well. But thanks to SARI North Central Sustainable Agriculture Research and Education Program for funding this project through a partnership grant. To give you a little bit of background on this project, we did paired field sites. So we had 3 different paired sites where we were looking for the same soil type and within a very small block, so we could contain that to the same soil type. We were looking for a conventional tilled field, a no-till field, and then a no-till with a cover crop. And we used these Meter Terros 11 sensors. So we had 2 of those sensors with each data logger. You can see the picture there of the sensor with the 3 prongs. We put those in at 3 inches and 6 inches. And then the data logger went up on a pole in the field to identify where those were at. So our 3 paired sites, you can see on the map there, Champaign County, Madison south of London, and then on the Madison-Fayette line. So at each location there was 8 sensors total, so 2 in the no-till, 2 in the tilled, and then 2 in 4 total in the cover crop field, 2 where the cover crop was going to be killed prior to planting, and 2 where it was killed after. You can see a picture here where we put them in at 3 and 6 inches into the soil there. This is a picture at our Champaign site where you can see the cover crop was killed here on the right side of the screen and not killed on the left side there. Of course, with any field research, we had challenges. 2 of the sites ended up killing all of the cover before planting, so we weren't able to make the comparison of the pre and post plant there. And we also had 2 sensors malfunction, so we lost the data from those. So we really weren't able to compare the killing before or after planting. We only ended up having 1 site, and within that site, one of those sensors malfunctioned. So the data that we got just really didn't make sense there. This is a 2-year project, so the sensors have been reinstalled already for this coming growing season. So hopefully we'll get a better look at that in the coming season. But if we look at the data that we did get, if we're looking at just the cover crop killed prior to planting, no-till and till, here's our soil moisture at 3 inches, and we can see that the cover crop did stay have more moisture in it throughout the winter into spring, and it retained that moisture through the growing season, which I think is what most of us expect from what we've learned, those of us who've grown cover crops or not. And you can see this is % soil moisture. So over the 3 sites, the tilled soil did offer drier conditions, especially around planting, though not a huge difference between tilled and no-tilled. But then, of course, it was quite a bit drier by July and August. And then if we look at soil temperature, it stays pretty close throughout the winter into April. And then we see that separate out with the tilled ground, warming up a decent amount above the tilled and no-tilled in the spring, and then staying a little bit warmer through the growing season compared with cover crop and no-till. I did pull out individual sites, just the Madison site here to share with you today briefly. This is a look at March through April, the 3-inch moisture. So we can see the cover crop definitely had more moisture to it. No-till there in the middle, but throughout April it was kind of going back and forth between tilled and no-till. And then if we look at the moisture in July through September, we can see that cover crop held on to that moisture really until mid-August, where it kind of merged with no-till, both of them staying a few percentage points above the tilled ground. So as I mentioned, this is 1 year of research data, some complications and learning involved with that. Hopefully next year we'll be able to come back with more data to share with you and compare the 2 years with what we found. If you have questions, I'd love to take those here today, or you can reach out to either Elizabeth or I aside from today's question time. And again, thank you to SARI for their funding for this project.
Thank you, Amanda. I think this is a great project. I've really enjoyed working with you on it. And now that the sensors are out, I'm excited to see what our data looks like this spring. To wrap up today, I want to share a little bit about our soil health study that we've conducted over the last 3 years. At that time, we were approached by a group of farmers that were wanting to better understand soil health in their farm and wanted to know what some of these soil health tests that are on the market today mean. So we set out wanting to understand a few things. One, how management impacts the results that you get from these soil health tests, and then how that soil health value can impact or reflect yield on different farms, and then help you as farmers benchmark what a good soil health value looks like. For this study, we've used a whole field sampling strategy. We've selected fields from across the state, and from those fields, we would pull 10 to 15 soil cores and then aggregate and mix those for a sample to submit for analysis. In the first 2 years, we did look at the impact of depth on the results. So if you're interested in that, you can look back at our 2020 and 2021 reports. But for 2022, we just stuck with a 0 to 8-inch core. We looked at varying types of management across all of our fields, including fields in long-term no-till, fields that had been conventionally tilled, fields that had been cover cropped, and fields with manure in the rotation. We sampled in 2022 168 fields in 37 counties, and the tests that we ran included a routine soil fertility analysis, and then several emerging soil health indicators, including epoxy, respiration, and wet aggregate stability. An important thing to note from our results is that over the years, we have seen that soil health is highly influenced by your soil type starting out. So this chart shows a positive correlation between 3 of our soil health metrics and CEC. And so this information is important to keep in mind because what you can achieve in a certain field is going to be heavily driven by your soil type starting out. Over the years, we have seen the impact of no-till. Looking at that organic matter and epoxy, you do see that there is a slight negative correlation in the amount of organic matter that we're seeing or the amount of carbon we're seeing in that soil as time progresses. This maybe is not as surprising a result as you may initially think when you think about the material that we're leaving on the surface, not making it into the soil profile to really drive a growth in that carbon. Not necessarily surprising, but we did see a benefit of no-till to building that aggregate stability in our soil. So that is positive. When we looked at cover crops, we saw a positive influence with those soil health factors in 3 of the categories that we're showing today as a result of cover crops over time. I think this is very positive for folks that are wanting to build carbon in their soils. We are seeing in the fields that we've sampled over the last 3 years, this positive influence with that tipping point really about 5 years in, seeing that increase in organic matter. It is important to note, some of these fields have been in for a long time. The changes here are going to be small, but definitely a positive result that we're seeing. Now, new in 2022, we wanted to understand how, with these various factors, how they could impact yield, or what sorts of trends we saw with yield in these fields. So we had farmers alongside their samples submit their average corn and soybean yields for their field. And starting off here with organic matter, you can see that both in corn and soybean, as the organic matter in those fields increases, we do see generally an increase in yield, which is, I think, exciting. We saw very similar results looking at POC, which again is that active carbon measurement that we were taking in these fields. Again, that positive correlation, as that active carbon increases, so did the yields in both corn and soybean. And then finally, we're going to show here respiration. And again, a stronger positive correlation there with soybeans, but that same correlation with corn. So very exciting as we look at these traditional soil health metrics that we've been looking at over the last 3 years, seeing that there is, in a lot of these categories, that positive correlation in yield may have you thinking that it's worth looking into those past reports and diving into how management practices can change those values over time, and what you can do on your farm to hopefully increase your soil health and then in turn increase yield. I've mentioned multiple times now that we have 3 years of results. One of the products of being able to have this large data set is that we were able to help put out a publication here that has some information that can help you understand, if you're pulling these values on your farm, where you fall. So that fact sheet is available at the website there. We can put that in the chat. But this publication summarizes what typical soil health values we saw in Ohio, and then benchmarks by soil type, since I mentioned earlier that that is important. So you can see by texture and CEC what quartile you fall in. So are you in the top 75% of soil in Ohio that we've measured? Are you about near the median, or are you lower? You can use these tables to determine for you if you think your soil health values are good and where you fall on that scale. Well, this is a great activity, I think, to understand where you fall. I do want you to keep in mind that when we talk about soil health, the best way to measure success is to look at your results in that own field, in your own fields, in that same field over time. So this is helpful information, but keep in mind that measuring against yourself is the best way to measure the progress that you're making. So please remember to check out the 2022 eFields report. Today's presentations were just a small sampling of the information that's available in this report. Scan that QR code and read through and see what there is to learn. And if you've got any information that you think should be added to future reports, don't hesitate to reach out to us. At this time, please take a few minutes, type in any questions you've got for our speakers today in the Q&A, and we'll take your questions now.